Hey, Intro to Calc. If you missed office hours on Tuesday and Wednesday, I'm super bummed. I had mentioned early on that this is one you really needed some instruction on, so I was going to do the task with you. So I'm going to make a very quick video just kind of introducing you to what this looks like. But I want to tell you this does not replace coming to office hours. This does not replace coming to office hours. So please make sure that in the future you make that time to come to office hours, especially when it's brand new content. So welcome to integrals, guys. Welcome to integrals. Today we're going to kind of talk about what this means right here. If you saw earlier in the task, it actually has this function 9 minus 2 to the x dx. And what this entire statement is saying is it wants to find the area between this function 9 minus 2 to the x and the x-axis. I want to know what the area is between that function and the x-axis. So let's start by graphing that function. I'm going to start by just kind of plotting some points. 9 minus 2 to the x, when I plug in 0, that's 9 minus 1, which is 8. When I plug in 1, that's 9 minus 2, which is 7. When I plug in 2, that's 9 minus 2 squared, which is 4. So we're plotting 5. When I plug in 3, that's 9 minus 2 cubed, which is 8. So we're left with 1. And my graph is going to go off at this point, so I'm going to go ahead and connect those in a nice smooth curve. And there we go. So what is this notation telling us? It's saying we want the area underneath this curve. So just to kind of give you a quick visual, it wants all the area underneath this curve all the way to the x-axis. But it also gives us some boundaries. It tells us between 1 and 3 only. So I'm actually going to cut it right here, just 1 to 3. To kind of like give you that visual, just 1 to 3. That's the area that I want right there. But that's not regular. That's not something that I have an equation for. It's not really a circle, so I can't use pi r squared. It's definitely not a rectangle or a trapezoid or a triangle. It's none of the above. So I have to kind of get a little bit more creative about how I want to break this up. So that's where it actually tells me take some vertical lines and let's draw them at 1, 1.5, 2, 2.5, and 3. So let's do that now. Let's draw in a vertical line at 1, 1.5, 2, 2.5, and 3. And if you guys are using the GoFormative has a straight line tool. It's amazing. Use it. So now we have these vertical sections. We can think of this as section 1. This is vertical section 2. This is vertical section 3. And this is our vertical section 4 that take us from x equals 1 all the way to x equals 3. Why are we just going from 1 to 3? Well, our integral right here says just from 1 to 3. From 1 up to 3. So now let's estimate the area. So you're going to see two different ways to estimate the area. One of them is by making rectangles. So I could make rectangles for each of these points. And that'd be a good approximation, but if you notice that if I make the rectangles connected to the left side, they're all a little bit over approximated. So I could also make rectangles this way. Rectangles all connected to the right side. But here they're also now just an approximation and an under approximation. So you could go as far as to make some trapezoids. I could connect from point to point, from point to point, from point to point, and from point to point. Now, that's not exact, but that's so much closer. That's so much closer. So I'm feeling like I want to do it this way. I'm wanting to use those trapezoids. So let's do that. Let's actually use some trapezoids. Okay, let's find the area of each trapezoid. I want to remind you guys that the area of a trapezoid is 1/2 Usually, a rectangle is length times width, but a trapezoid has two different lengths. There's not just one standard length, there's a length on each side. So I'm going to say length 1 plus, let me make that cursive so it's a little bit clearer to see. Length 1 plus length 2, it's the average of those two lengths times the width. Okay, let's start with our very first trapezoid. This is our first trapezoid right here. Well, we know that the length to this point right here is 7. We don't know the length to this point, but we can reference our equation and actually plug in 1.5 to our equation. When we plug in 1.5 to our equation, that's 9 minus 2 raised to the 1.5, we get about 6.2. Or if you want to be super precise, 6.17. So when we do our area of just that first trapezoid there, I'm going to use the sub 1, so it's the first trapezoid. We have 1/2, one of the lengths, the other length, and our width. Well, what is our width from 1 to 1.5? It's just a width of 0.5. So 1/2 of 7 plus 6.17 times that 1/2, which is the width. And we get 3.29. Cool. Let's do the second one now. This is our second trapezoid. And I want to remind you at this point that if you're coming across an idea that is something a middle schooler couldn't understand as far as area goes, you're thinking too hard. We want to just stick to simple area forms, rectangles, trapezoids, triangles, anything you can. So the area of the second section is another trapezoid. The height or length on this side is 6.17. And this one was a solid point on our graph of 5. But the same width right here from 1.5 to 2 of just 0.5. Okay, let's see what we get there. So 1/2 times 6.17, that's one of the heights, plus 5, that's the other height, times 1/2, and I get 2.79. Cool, let's keep going. Let's look at the next section. Here is our next trapezoid. Same exact equation. 1/2, that first height right there is 5, or that first length is 5. That second length we do not know, but remember this is 2.5, so we can just plug it right back into this equation. 9 minus 2 to the power of 2.5 is about 3.34. So that's what we want to add on. Same width though. Same width from 2 to 2.5 is just 0.5. So pop that into your calculator. 1/2 times 5 plus 3.34 times 1/2, which was our width. And we get 2.085. Okay, we're almost all the way there. We wanted to go from 1 all the way to 3. This next region will take us all the way to 3. So this last trapezoid right here takes us all the way to 3. The area of our fourth and final trapezoid is 1/2. The first height right here, which is 3.34, we found that in the last one, plus this height right here, which is just 1, times our width. Well, our width is that same value right there of 0.5. So 1/2, 3.34 plus 1 times 0.5, and we get 1.085. I'm going to stop for a second to just kind of verify that this makes sense. I kind of like to always come back and make sure this makes sense. Our largest trapezoid right here had the largest area. This one was a little bit smaller. This one was a little bit smaller. This one was the smallest. That makes sense. That means I didn't make a major miscalculation. And let's move forward by adding all of these areas together. Let's add them up. So the total area is going to be that 3.29, the first trapezoid, plus 2.79, the second trapezoid, plus 2.085, the third trapezoid, plus 1.085, the final trapezoid. So what is the total area? Let's type that into our calculators. 3.29, oops, 3.29 plus 2.79 Sorry guys, this is where my little tiny phone calculator is not my best friend. It takes a while to type in. Cool, and my answer is 9.25. It is square units, but I asked you just to type in the number so it could correct it if it's right or wrong. This is the big idea of this module. This is the big idea of this part of the module, that we can find the area under a curve with these approximations. We don't have a formula for this perfect curvature right here. We don't have a formula for it, but that's okay. We don't need a formula for it because we have approximations. And so that's what we're going to be really diving into, approximations. So this notation right here means find the area between the curve, that's this guy right here, and the x-axis, this guy right here, between 1 and 3. It's actually calling out this region that we shaded in. Hopefully this helps if you weren't able to make it to office hours. Please do your best to get to office hours later this week. Period 2, your office hours are on Thursday at 11 a.m. Period 3, your office hours are on Friday at 9 a.m. But if you don't have a conflict, feel free to come to either or both. See you guys soon.